Hey, this is TJ of ShopBot Tools. Today we're going to do a lesson on pocket and profile toolpathing. These are two common toolpaths that are used in a lot of different projects, and though they might seem basic, there's a lot to them, and they can be used in a lot of different applications, and sometimes one is going to be more beneficial to use than the other. So I'm going to show you a few different projects here where this might be the case. So first, let's start up by opening up a VCarvePro file here. And what I've got on here are two 6-inch circles. And just to show real quick what the difference between a pocket and a profile is, I am going to open up the Toolpaths here and preview these out so you can see. So a profile is where it just cuts around the vector line, where a pocket, it'll actually take everything out that's in between. So what we're seeing in 3D view here is we're seeing a kerf that's the thickness of our cutter that makes a pass all the way around. Or in a pocket, it takes everything out in between. So let me go back here to the 2D. Here's the same circle, and these are the two different vectors that we profiled and pocketed. And now let's look at them in 2D view. By clicking the solid, I click the profile. The profile is showing this blue here is the cutter. This is the kerf that's going to go around the circle, and that's showing that it's going to go all the way around the outside of that vector. The pocket over here, that's showing that it's going to pocket out everything in between. So the point of today's training is profile and pockets might be pretty simple, but there's times in your projects if you want to use your CNC machine, which is our ShopBot here, that's going to cut out this accurate part exactly how we drew it. Sometimes it's more beneficial to use a pocket on the inside, maybe pocketing out a handle or something that saves you extra work after the machine is being done cutting with the ShopBot. That'll take it so you don't have to get a file out or a sander or anything. So we're going to look at the two different types here. So let's step back and actually look at these pockets and profiles being used in a project. So let me close this out, and let me bring up a picture here to show you what we're actually going to be file we're going to be working with. So this here is a patio chair, and you can go to shopbottools.com and look under the ready to go projects and download this project for free and cut it out. It's a nice beach chair that folds up, easy to carry to your favorite campsite or beach location. So the way this project goes together is it uses a mortise and tenon joinery system. So these mortise and tenons get glued together and then pushed together, and when the glue sets up, the chair is held together with no outside fasteners. Here's glue being put down inside of the mortise. So in other words, what this is a pocketed out square. We use the pocketing toolpath to pocket that out. So notice it's not all the way through, it just has a certain depth. And then those pockets get pushed onto the tenon of the leg, which is the little tooth that is hanging out of the bottom here. And then, there's just showing you the joint, wipe away any squeeze out of glue that you have. So this is the file we're going to be looking at. We're going to be looking at the VCarvePro file for this patio chair. And let me bring that up. So for this patio chair, this is what it looks like when it's all nested into a sheet of a 4-foot by 4-foot sheet. So right here I have a 48-inch by 40-inch piece of plywood. It's Baltic birch. It usually comes in a lot thinner. It's not a true 3/4. So use your calipers to measure that. And I am going to zero to the machine bed on this because the majority of my cutting is going to be through cuts, and I want to make sure that I cut all the way through around these. There's nothing more aggravating than not cutting all the way through. So if you zero to the machine bed and cut there, you're going to make sure you've ensured that you've zeroed to the lowest point. Plywood thicknesses come in very inconsistent, so it's ideal to zero to the machine bed for a project like this. So just looking at the file real quick, I can see here's those tenons that are sticking out. Here's the tenons, and these little corners here are around those are the dog bones that you find underneath the fillet area. And the reason for that is if you didn't have these, you ideally it'd be nice just to have that square corner. But in a CNC world where we're using a round bit, you can't cut a square corner, and we end up with something like that. And with that being like that, the slats up here, these would not go down, these would not fit down in there. They wouldn't be able to seat all the way because the fillet would be in the way still. So let me just edit undo that. And so we can see here that we've got some pockets, and we can see that we've got a lot of profiles that will be going around, a lot of through cuts. So let's take a look at the toolpaths, for instance. So first of all, there's a hold down one, and that's where these different screws here are put. These are locations for different screws that would be out in the center of the plywood. So we actually use the ShopBot to run a hold down toolpath, which is just going to go down and do a drill of 0.05 in these different spots. Then we'll move the gantry out of the way, and I'll put screws in those areas. And the way those are drawn on here is they're in areas that are far enough away from where the cutter will be cutting. So it's a nice way to hold things down if you don't have, say, a vacuum hold down. Alright, so let's just do a quick 3D preview of this. So first thing first, there's your hold down. So I would run those hold downs, and when that's done, I'd move the gantry out of the way, and I'd come and I'd put screws in all those locations. Then we'd come back and here and run the pocketing toolpath. And what that is doing is it's pocketing all of those holes out, the mortises for the tenons to go down. They're at a certain depth. They're not all the way through. So the pocketing toolpath, you can go to different depths. And then finally, the last toolpath that'll come back around this is profiling the through cut all the way around the parts. So there's the order that it would cut it out. I can see blue through there. That means that I have cut all the way through. I've got a thing here called tabs that are holding those parts in place. That way they're not moving around. Once they're cut all the way around, they need to be held. Otherwise, if they didn't have those tabs holding them in place, that part would move, and it would move into the cutter and cut into your good finished piece. So let's look at these toolpaths. Whoops. Let's look at these toolpaths a little bit more depth. Let me delete all the toolpaths, and we have our drawing, and we need to retoolpath that. So the first thing we're going to do is I want to create a pocketing toolpath, and if you hover over these, they will tell you what the name of the toolpaths are. So the pocket toolpath. So the first things in here would be start depth and cut depth. A lot of people, when they first get started, they get a little confused with what start depth is, and they associate it with how they've zeroed their machine. It has nothing to do with how you zeroed it. If you look over here at just this little icon, that little D, which is the D here, shows you what that start depth means. And to bring up a project to show you, look here at this. This is a little plaque that shows a lot of the different types of cuts. And how is this ShopBot V-carve down inside of this piece of material? Well, what I've done here is I gave it a start depth of the depth of that pocket. So the machine went and pocketed out this rectangle. Then I did a V-carve, and I gave it a start depth. So unless you want to cut down into a pocketed shelf, there's no need to ever put a start depth in there. It has nothing to do with zeroing either. So more than likely you'll leave this at 0, 0 for a majority of the cutting, unless you need to do something down inside of an existing pocket or something else special down the road. So I don't need to put a start depth in there. Cut depth, now that's where it's important. I measured the length of my tenons here. If I measured how tall these tenons are, that would give me how deep I need to make my cut. And I even make it a little bit deeper because I want to make sure I've got room for glue and stuff in there. So I've given myself a little bit of a 10,000th of a tolerance to have room for the glue. So my cut depth is how deep I'm cutting down into my material. Next thing is you got to select the tool that you're going to use. What are you actually going to cut this out with? So the way these were designed, they have a 1/4 inch dog bone on them, so they're designed to be cut with a 1/4 inch bit. And here's where you'll go into your tool database. And where is this tool database? Well, if you come back to our website, you'll see that under the training we have another training on tool database and bit selection. But for this, I'm just going to stick with the 1/4 inch down cut that I'm using. And I can tell this to do a offset or a raster, and just by clicking on the picture you'll be able to see what they are. A raster is really nice. Say you had a grain that you wanted to cut with, the grain of your wood you wanted to cut back and forth with that, you could actually change the raster. I'm just going to go in with an offset and let it just pocket the thing out with plywood. Climb and conventional. This is where you can tell it to go clockwise or counterclockwise. Typically for cutting plywood I like to use a conventional type cut. When you do use a raster, you can give it an angle. Maybe you've got your material on there at 90 degrees, so you'd like to give the raster angle, and then it'll have a profile that you could do first or last. So depending on the application and what type of cut you're doing, this can be very, very useful. This raster is a very powerful thing here. But I'm just going to stick with the offset for pocketing out plywood. A ramp is something that's really nice to add in there too. So a ramp, what it does, instead of making a straight plunge, underneath your tool database here, you have a plunge rate. That is how fast it's going to plunge straight down into your material. Right now it's set at 1/2 inch per second. So that would be plunging down. Maybe this was a piece, we were going to cut this chair out of some hardwood, say like a white oak or a sugar maple. I wouldn't want that little 1/4 inch bit to go jamming down into that material, so I want to add a ramp to it. So then what it'll do is it'll ramp down at a nice easy distance of what you set, and then after it gets down to that distance it will make the pocket, and it will go back and clean out where it initially ramped in. So that's a real nice feature to have. A ramp will add a little bit of a time to a cut, but what it will do is save life on bit wear and tear and spindle plunging down into your material. Right now we're just using plywood. There's not much as far as strength, but I'm going to go ahead and leave the ramp on there. And if you want to get in here to vector selection in this, also refer back to our training page. There's stuff on tool selection by using the selector, where you can actually do vector selector using layers. And then I like to give it a name that I know what it is. Pocket 1, if I had several different pockets going on, that could get a little confusing in my tool list over here. So I'm just going to tell exactly what this is. 0.5625. And the final thing that you need to do is go and select your vectors that you want to pocket. So right now I'm going to select these, and holding the shift key on my keyboard, it allows me to select multiple ones. So let me just select these, and again I'm holding the shift key down, and then I'm doing sweep selects over these. And if you accidentally say you highlighted something that you didn't want, you can just click on it again and it will deselect itself. And I'm going to hit calculate, and here we go. Let's reset the preview, and I'm going to go ahead and preview the visible toolpath, and there I can see my pockets, and I can see I've added, want to make sure I've got dog bones or T-bones on these, on all the, I'd want to inspect all the different ones and make sure they're all there, otherwise my project's not going to go together. And let's see here, the next thing we would do would be, if we're happy with the pockets, now we need to move on to the profile toolpath. So the profile toolpath is this very first one here. I'll hover over that, and notice that my pockets are still selected because that's the last vectors that I was working with. So I'm just going to click over here in the gray area, and that selection will go away. So next thing here, we're seeing sort of the same screen as before. Start depth. Are we starting down into the material? Are we starting down into an area? No, we're not. We want to start right from the top of the plywood. So I'm not going to put a start depth in there. Cut depth. Well, the thickness of your material, you could set it for that. But as you'll find, material has a lot of variations in thicknesses throughout, and you can only put your calipers around the edge of plywood. You can't always get it in the middle. So what I like to do is if I type in Z here it will actually, the software will actually grab the thickness of the material. So look here, if I went Z equals, there, it's going to change to 0.69, which is way back to that job setup we were originally looking at, where our material thickness was right here, 0.69. So instead of going back and referencing, I can always type that in. And I would like to actually cut down into my spoil board a little bit. That sacrificial board is there for us to cut into. I'd rather be down in there 10 thousandths than not all the way through. So depending on the quality of your plywood, I'll go anywhere from 10 to 20 thousandths deeper into the spoil board. So there's the material thickness, 0.69, plus 10 thousandths, which is just the thickness of a couple sheets of paper. And I'll hit equals, and there, that gives me my cut depth. So that is a cut depth of 0.7 of an inch. Now a lot of you are asking, well, that's a pretty deep cut. If I have a little 1/4 inch bit trying to cut 0.7 deep, I'm going to start snapping bits. So this is where we'll have to start getting into feeds and speeds and pass depths. And again, refer back to our training page where there are specific trainings covering those individual topics. But keep going with the profile toolpath. I go in here and select a bit. Now that I'm not doing a pocket, I want to cut these pieces a little bit faster. So I'm going to select my 3/8 compression, which allows me a bigger bit, which allows me to cut harder and faster on our alpha spindle machine at the back. So I'm going to actually do a bit change, but doing the bit change, I'm going to now be able to cut quicker. So this now has 2 passes where I could even set, depending on your machine, this is going to be where you'd come up with your different depths. Okay, so machining vectors. You notice here you got options: outside, inside, or on the line. And when I click on these different things, this changes over here. And what that's doing is that is showing you where the bit is. That little yellow circle is the diameter, is your bit. So how would I want to machine these? The way I've drawn these is if I machined inside the line or on the line, it's not going to come out to the dimensions that I drew it at, so that part would not come out right. So you need to make sure you know how you drew your project. I'm going to show you a little bit later where we actually use this profile toolpath to machine inside or on the line. But for right now, we want to machine on the outside of the parts. Again, climber conventional, as I said before. For plywood, I like to cut conventional. Allowance offset. So this is where you could actually build in an allowance to have it cut inside of your part or outside of your part, and we'll come back to that in a little bit. We do not need that right now. We want to cut exactly to how these are drawn. And we've got some options along here. We've got some different tabs that we can select, and these are some different options for profile toolpaths. The first one I want to look over here was we're familiar with ramps. We just looked at those. And here there's different types of ramps, and I'll come back to showing you these in a little bit, but right now we'll just select a ramp that ramps down at a smooth distance. Right here we got a smooth angle coming down at 4 inches. So over 4 inches it's going to ramp down to the first cut depth is what it's saying. So if we're cutting 0.7 deep and we're doing it in 2 passes, we know that our pass depth for our first cut is 0.35. And to get to that first depth, instead of just jamming down to 0.35, it's going to gently, over 4 inches, ramp down to that 0.35, make the first pass all the way around, clean up that ramp, and then second depth, make the second pass, go down to the 0.7, and go and run around again. So for this tour, we want to add tabs, and I showed you those in the initial preview. How do we keep that scrap piece? How do we keep the parts and the scrap pieces on there? Well, we use hold down screws to hold the plywood to the ShopBot, but how do we hold these pieces, the finished pieces, to the scrap once they're already cut? Well, that is where we use the tabs. And for this here, going to use a 0.4 length, a 0.24 thick, and a 3D tab. And this is a good size tab for this plywood. It makes it real nice so when you're done with the project, you can flip the part over and nip those tabs with the utility knife and then go touch them up on the sander if need be. So this is where we got to select the vectors. So I will select these. Now these already have tabs on them because they were previously Toolpath when we brought this up. But if you wanted to go in here and say edit these tabs, or you didn't like any of these tabs, this is where you would go in here. And you can have it add tabs manually for you by selecting the number. You could delete all tabs if you didn't like where they were. Or you can come in here individually and say, I got some tabs in some places I don't like. And if you read here, it'll just say hover over, and you hover over a tab you don't like, it'll get rid of it. And a couple of them here. And notice where some of these tabs are. I've went in here and put these in areas where it's going to be easier to clean them up for me when I'm done. They use the CNC machine to cut you this nice accurate part. So if you had a tab right here, that's going to be really tricky to get in there with a file and a spindle sander and try to clean these little spots up. So ideally, take the time right now and place the tabs in a convenient place for you. I like to keep them across from each other so that way they'll help with strength of the part. I like to put them in places where I know I can easily get to them with a sander. This is something I can walk up to a disc sander and easily clean that up. I know this being on the top of this tenon, if I go to sand it and I don't get it all, I take a little too much off or it doesn't look pretty, it doesn't matter. It's going to be down inside of a glued up joint. So I'm just going to kind of look over. I got these all opposing each other because there's not going to be a whole lot of material left in here. So if I have tabs across from each other, it'll help build strength. And I see another part here that I should have selected, and I go in there. So these are tabs on the handle as well. And we're going to come back and look at that handle here in a little bit. So if we're happy with the tabs, I'm going to keep moving down, and I'm going to call this profile all parts and hit calculate. And it does give you a warning message here, and it would be to your best interest to always read this message. You're going to see it a couple hundred times here once you get cutting. And the day that you don't read this and verify what it says here, material thickness 0.69, maximum tool depth 0.7. The day you get into the overconfidence mode and hit OK without reading that will be the day that you accidentally had this decimal over here and it would say 7.0. And I think you know where I'm going from there. We'll leave you with your imagination. But preview this out. And there we go. Here we see our stuff. So there's just a quick look at a pocket and a profile toolpath. That's all it's needed to cut this patio chair out. But there's going to be some other things that we could go in here and do to make our life a little bit easier. First things first is let's look at this project. So that we know right here that this is a handle that needs to get cut out of here. And look at what kind of material we got left here. We got just a thin strip of wood, and we got 2 tabs. Well, anybody when you starts cutting, start knowing that tabs are nice. They do a good thing, but they take some time afterwards to clean up by hand. So when you can avoid them, that's nice. If you have a vacuum table or you have bigger parts. For us right here, this is kind of a little spot that would be kind of annoying for some tabs. So I gotta go in there and try to clean that up, cut them out of there, and then get a tiny little spindle for my spindle sander and clean them off. Well, after cutting a couple of these and going, hey, if I got 50 of these, I got to make at a time. That's a lot of handwork. I got this nice CNC ShopBot sitting over here. Let's make that thing do what it's supposed to do. So let's look at this handle a little bit closer and look at what we have for options. So here's the handle, and let's look at it from a pocketed point and a profile point. So far we've only seen this as the profile, which is on our current handle. There's the tabs, there's the little material left in there. Now let's look at it as a pocketed one. Preview this one, and see it takes all the material out of there. Now I have no tabs to clean up, and the machine has just made the handle the way it's supposed to be, with no outside cleaning for me. So there's looking at the pocket and the profile. And what we're looking at here, really, if you look under the summary of toolpaths, is the time difference. So to pocket that out with the same bit and same fees and speeds is less than a minute worth of cutting. So think about that as a production setup. So like I said, sometimes I'll get orders of these for 50 at a time. Well, okay, there's 50 extra minutes cutting. You're like, that's 50 extra minutes cutting. That's a long time. But that 1 minute, are you able to pull those 2 tabs out of there? And are you able to sand that up nice and clean in 1 minute? Probably not, no. That takes a lot of work. And really what this comes down to too is that minute, this is just using the same feeds and speeds to show you the difference. If I really went in here to this pocket, I bet I could come in here and speed this up and have this cut a little bit faster, increase step over, and probably get it so it's less than 30 seconds per pocket versus profile handle. So this is where I would choose to use a pocket over a profile. And the reason for that is some people might say, well, just don't put any tabs on it. Well, what's going to happen if you don't put tabs on that? That piece will come loose. That little piece will be moving around in there. Let me take the tabs off, calculate, and read that message like I said. And now let's preview that. And there's no tabs. So what's going to happen? That piece in there is now going to come loose, and more than likely a loose piece will shift, and if you're using a small 1/4-inch bit, it could have enough power to snap that bit, which is no fun. So I choose the pocket on this one. Let's look back here at cutting some profiles in different ways. I'm not going to save these. Let me get out of here. And what I want to look at here is this is called a Labyrinth, and these are used to help calm, certain special needs students down. Helps get people their focus on anything but what's getting them a little agitated. I've been cutting a lot of these lately for my wife's birthing class. So in the birthing class, the women will run their finger from the start here through the labyrinth all the way back around to the finish, and you close your eyes and try to do this, and it will take the thought away from the the hard breathing or the pushing that you're going through and help you concentrate on the breathing. So let's look at this project here. So here is the labyrinth in vector format, and you can see here that I have a profile for the groove and a profile for the outer. There's no pocket on this one. The reason there's no pocket for this one, this is just a open vector. It's not an enclosed area like we saw before. So this one here, this was just drawn with a single line. And then if I look in here at profile groove, here is a profile toolpath that is now machining on the line. So that means my bit will be centered over this vector. There's no tabs because I'm not going all the way through. And let's take a look at what that looks like. So to profile on the line, there's the ramp down in, and then it starts making the run. And it's kind of neat to watch this one cut. It's just like the machine's running it too, running through the labyrinth. So if you're watching a preview like this and it's going really slow, what you're going to want to do is maybe go back and check your feeds and speeds. Maybe you don't have your feeds and speeds right. If it's down here saying simulate toolpath and it's taken 2 or 3 minutes to do this, something is probably wrong with your feeds and speeds. For me right now, it's because we're recording, we're on go-to meetings, we've got so much going on with the PC, it's just overloaded. So, but that's what it's going to do. It's going to preview what the machine's going to do. So whatever you see here is what you're going to see out on the machine. But if it's something you don't want to sit and watch the whole thing, you can always just click out and stop the toolpath. But we get the gist of what this is by looking here at this labyrinth. So it was cut on the line, and then it was cut outside the line. And notice if you accidentally were in here and you had it grabbed, you selected the wrong one, and again we're reading those messages, if you had selected the wrong one, it's going to show up here in preview, both 2D and 3D previews. Right here, by me clicking these, I can see the blue is where it's going to cut. And this profile outer, it's on the wrong side of the line. It would leave a really, really small edge right there. I can just double check my work by looking at the previews before I go out to the ShopBot and cut. So I got to change that back. And if I notice now, boom, the blue line's on the back side. So if we look here at this project, let me bring up this. This is something called Essential Cuts. And I like this project because we cut them out of scrap materials from our handybots, and then we give them out to people that come through trainings here, and you can see the different types of cutting that are done on a ShopBot. So just to look over this here, we can probably see a few profiles that we've used. You know, there's profile outer around that. Here's a profile that was cut with tabs. This one up here wasn't actually even a profile. This was an inlay, or you can do a male and a female. It's another toolpath. Here's a profile on the line for the star. Notice the profiles don't have to go all the way through. I didn't want that star pocketed out. I just wanted the vector of the line. Here's a pocket where this is pocketed out, and then there's a V-carve down inside. That's where they have the start depth. This is a texture here, a texturing toolpath. And again, here's with our inlay to get that to fit. This one here is a fluting toolpath. So there's a lot more different types of toolpaths than the two that we covered today. I would go in and play around with them, check them, see them in 3D preview and 2D preview. What you're going to see on your machine is what you're going to get. So I guess I'll leave you with this: is, you know, sometimes it's more beneficial to use a pocket, and sometimes it's more beneficial to use a profile. Think about what you're working on. The handle of that patio chair, it makes more sense to pocket that. To cut that out and only have, you know, 30-40 seconds added on to the machine cutting versus you doing it manually by hand, it's more worth the while. Same thing here. Do you think I wanted to switch bits and have a 1/4 inch, a 1/2 inch, and a 3/4 inch bit? That's 3 different bits. No, I don't have to do that. I can just come into the file and have it do the through holes as one toolpath. Here's using a 1/4 inch bit, cutting through the material, doing all 3 of those holes. And here I'm using a pocket where I'm cleaning out everything in between. And the other thing you need to think about too is what somebody say why not do a profile? Well, that could leave a little bit of some profile inside the line. That could leave a little bit of scrap right here, and that could be enough scrap that would come up and break your bit. So that's one bit using to pocket all 3 of those out. And the last thing is back on this patio chair is when you're doing this chair, when you're doing projects that have vectors inside of vectors, notice how we originally had this cut as outside parts. We actually had the handle as part of the profile. When you're selecting the vectors for these, you don't need to make a separate toolpath for this one to cut inside the line. The software is smart enough to know that when you do a multiple vector like this, here are the arrows cutting on the outside of that, and then here, if you look in, it knows to cut on the inside. So you don't need to make separate profile toolpaths. By selecting both just like that, the software knows to stay on the outside of the part. So it would actually be on the inside of this handle, but again, it's on the outside of the part. So the software can figure that out on its own. You don't need to make multiple toolpaths. There's simply a pocketing toolpath, on a profile toolpath. That is all that's needed for that chair. And if you don't have vacuum, you'd want to do some sort of a hold. So get in here, play around with your software, play with the pocketing, play with the profiles, and look into our other tutorials. And Vectric has several awesome tutorials on their website too. Get on there, read up on this stuff, and have fun ShopBotting.